When you type google.com, your computer has no idea where Google actually lives.
It only understands numbers, not words.
So, how does it find the right place in less than a second?
Your computer does not store the locations of websites, so it doesn't know where Google is, or YouTube, or Instagram. What it actually needs is an IP address.
Basically, an internet home address written as numbers, like this. Without that number, your computer can't send data anywhere.
This is where DNS comes into play. DNS stands for Domain Name System. It's essentially like the internet's phone book. When you type in a website's name, like google.com, DNS looks at the exact same number address so that it can match it and you can send a request.
Wait, who is actually providing this DNS server? And who answers your DNS request?
First, your computer sends a request to a recursion DNS server.
Now, this is usually run by your internet provider.
If the server does not already know this answer, it acts as the root server, the highest level of DNS in the world. Then, the root server points to something called a top-level domain server, like the one that manages all the .com websites. That server finally sends a request to an authoritative server known as the actual IP address for google.com.
This all sounds slow, but it feels instant because of something called caching. Caching means that your computer and your internet provider temporarily save the DNS answers. So the next time you try and visit a website like google.com, your computer doesn't have to ask all those servers again.
It already remembers.
Does this really happen every time someone opens a website?
This process happens billions of times every day for billions of people. Without DNS, you have to memorize the numbers of every address for every website. The internet wouldn't feel fast, simple, or human. It would feel broken.
So the next time you type google.com or any other website, your computer does not know magically where to go. It asks a global system for help, and then the system responds in a second.